In 1997, a survey of 840 households showed that 131 of them use email. Use those sample results to test the claim that more than 15% of households use email, use a 0.05 significance level. So here's the claim that more than, that's a key word right there, more than 15% of households use email. So we have null and alternative hypotheses. The alternative hypothesis always contains the inequality symbol, and the null hypothesis always contains the equal sign. So alternative hypothesis would be p greater than 0.15. And then the null hypothesis, p equals 0.15. So we're testing a claim that more than 0.15 households use email. But what we're going to do for the purpose of this test is, let's just say p equals 0.15. We're going to test a claim. We know that the claim is going with the alternative hypothesis. We're going to test a claim p is greater than 0.15. And when we test a one-tailed claim, this is a one-tailed, it is right-tailed. When we test that, we're looking to see if we have enough evidence to either support or not support. So we would say there is sufficient evidence to support the claim, or there is insufficient evidence to support the claim. If the test statistic falls in the critical region, we are supporting the claim. If it does not fall in the critical region, there's not enough evidence to support that claim. Find and graph the critical values. So in the previous page it said that significance level alpha is 0.05. It is a one-tailed test, and it is right-tailed. It said p greater than 0.15. That'll make it a right-tailed test. We are using the z distribution. The area of this tail then is 0.05. So we need the z sub alpha, which is the critical value. When it's a two-tailed test, it's z sub alpha over 2. One-tailed test, z sub alpha. So if the area of the tail, which is to the right of our critical value, is 0.05, the area to the left of the critical value is 0.95. We can use inverse norm to find the critical value of z, and you would get 1.645. You can also use the table if you wanted to. You would find the z such that the area to the left of it is 95%, 1.645. So if our test statistic lands in the region to the left of our critical value of z, we do not reject. If it lands in the region to the right, we reject the null hypothesis. So for B, the critical value of z is 1.645. C, calculate and graph the test statistic. So we need z sub p hat. So the z for our test statistic, p hat. So it's p hat minus p over the square root of p times q over n. P hat, looking back at the problem, it said 131 of 840. So p hat is 131 out of 840 minus p, which is 0.15, divided by square root of 0.15 times 0.85. Q is just 1 minus p over 840, which is what n is. It's a z score, so we round to 2 decimal places, so 0.48. 0.48 is here. It is more than, right? 0 represents 0.15. It represents the population proportion of 0.15. 131 over 840 is more than 0.15. But is it enough more? Is it statistically significant that this sample proportion, which is more than 0.15, is it enough evidence to support the claim? Does it give us enough evidence to support the claim? Well, we're not in the region of rejection. We're not in that tail. So we're going to say, do not reject the null hypothesis. So here's our z sub p hat, which is that 0.48. it is in the region where we would say do not reject the null hypothesis. We're going to do a couple things before we actually state our claim now. Another way is to use the p-value method. So many times we're interested in p-value. So there's a couple different ways to find p-value. You can run this test actually on your graphing calculator if you wanted to, and I'll show you that. So we can go to Stat, we can go over to Tests. We're going to do a 1 proportion z-test, so number 5. What we want is the null hypothesis p, so that's 0.15. And then we want x, n, and then we tell it whether it's right-tailed, left-tailed, or two-tailed. X is 131. It's the number of people in the survey who actually use the email. 840 is n. That's the number of people surveyed. This is a right-tailed test, so you have to enter all that information in and then go to calculate, and it gives you everything you need. So you could see z equals 0.48. There it is. We just calculated that. P, which is p-value, is 0.3145. So we're going to take that to 4 decimal places. P-value 0.3145. And it even tells you what p-hat is. P-hat is 0.155952. It is more than 15%. It is more than 0.15. But we just found out that it is not significant enough to support our claim. So let's write down the p-value, 0.3145. There's another way to do p-value. And that's using the table, or we can use another function on our calculator. What the p-value actually is it's the area. If you take your test statistic, so we take the test statistic, it's going to be the area from the test statistic to the extreme. So the p-value is actually all of this area. We could tell right now that the p-value is greater than the significance level. That's another way that you can draw a conclusion to fail to reject the null hypothesis. So what you want to do is you want to find the area to the right of 0.48. And if you use the table, you will actually get 0.3156 for your p-value. So using the table, we get 0.3156, which is the area to the right of z equals 0.48. You could also, if you wanted to, do this. Use normal CDF, and the lower, since we're finding the area to the right, the lower boundary is 0.48, the upper is infinity, but we can't type that in, and we're in the standard normal distribution. This actually gives us 0.3156 as well. This one gets you an answer closer to the table. So the p-value is, both are accepted, 0.3145 from the calculator, z1 proportion z-test, or p equals 0.3156, which comes from the table. In both cases, the p-value is greater than the significance level, which means that the test statistic that gives us this p-value cannot be in the critical region. Therefore, and also just by looking at where it's placed, we can tell the test statistic z sub p hat is not in the critical region. Therefore, we fail to reject the null hypothesis. And I'm not going to write this down just because it takes too long. But the way to actually interpret this, since the claim was with the alternative hypothesis, p is greater than 0.15, we are looking to see if we have enough evidence to support the claim, or if we don't have enough evidence to support the claim. In this case, we do not have enough evidence, so there is insufficient evidence to support the claim that more than 15% of households use email. So when you fail to reject and it's a one-tailed test, there is insufficient evidence to support the claim.